and right triangle is there. And here two situations can arise. One is angle of elevation, when the observer is standing on the ground and watching a tower against him. So then this angle is called angle of elevation. But if the case is he is standing on the height or top of the tower and he is watching something on the ground, so then it becomes angle of depression. And the line which is cease, that is hypotenuse, will be always line of sight. So these two are line of sight. Now let us understand angle of elevation with one example. Suppose there is an electric tower and a man standing here is putting a ladder to climb it up. So it is said that this angle is 60 degree. The ladder is kept at 60 degree. This is the tower AB. Now tower will be always vertical and the distance between them is 15 meters. So you have to find the height of the tower. Here basically always we will be using either tan or cot. In some of the cases only we will be using sin or cos. So here I want to find the height of AB. So first I am taking let AB be h meter, BC equal to 15 meter, that is given, and angle C equal to 60 degree. These three things I want in this sum. Now I can use tan 60 equal to opposite. So AB or perpendicular. So that will also be AB upon adjacent. So that is BC. So tan 60 is root 3 equal to AB upon 15. So I can say K height of the tower or building, whatever it is, will be AB will be equal to 15 root 3 meter. So this is how you have to solve here the sums. Now let us consider one more pattern of sum where here one situation is this and the other situation comes when we are on some height, that is observer is standing and watching. Now let us take one example related with that also. Suppose this is a top of a building and now I am saying one student is standing here and he is watching from here, that is eye level, he is watching the top of the tower. So his eye level will be this line, the dotted line will be his eye level. Let me give the name D, C, D and A, and let me give this as E, and let us say that this angle is 45 degree. Now and DC is 1.5 meter, so this also will be 1.5 meter because he is watching in a parallel line. So he is asking me to find the height of the building. Now see here only one thing I am given, that is angle and my height, or the person who is standing, that person's height. So I can say angle D will be 45 degree and the other thing I am given DE equal to EB equal to 1.5 meter. Now he is asking me AB. So to find AB, see the first thing I am clear, AB equal to AE plus EB. Now if I take the relation of tan 45, that will be AE upon DE. So tan 45 is nothing but 1. AE I don't know. DE also I don't know. But here I came to one relation AE equal to DE. And let us say this distance is something 28.5 meter. So same, this distance also will be same. So now I can say this both distances will be equal to 28.5 meter. So therefore AB will be nothing but AE plus EB. So AE is 28.5 plus 1.5, that is the height of the person. So this will be 30 meter. Now exercise 9.1 first question says a circle artist is climbing 20 meter long rope which is tightly stretched and tied from the top of a vertical pole to the ground. Find the height of the pole if the angle made by the rope with the ground level is 30 degrees. See, here AB is the required pole and rope AC is 20 meter high, angle C is 30 degree. So can I say sine 30 equal to AB upon AC? So sine 30 will be 1 by 2 equal to AB, I don't know, and AC, so that is 20. So from this I can say AB equal to 20 by 2. So therefore AB will be 10 meter. Now in the second question it says a tree breaks due to storm and the broken part bends so that the top of the tree touches the ground, making an angle 30 degree with it. The distance between the foot of the tree to the point where the top touches 8 meter. Find the height of the tree. So now see, if you see the figure carefully, AC is the required tree. AC is the tree broken from point B. A dash, angle A dash equal to 30 degree, angle C equal to 90 degree, and A dash C equal to 8 meter. So here I can use tan 30 will be equal to BC upon A dash C. So tan 30 means 1 by root 3 equal to BC I don't know upon A dash C is 8. So can I say BC equal to 8 by root 3? I want A dash B also. So can I say cos 30 will be equal to base. Base is A dash C upon hypotenuse. So A dash B. So cos 30 will be equal to root 3 by 2 equal to A dash C. So that is 8 meter upon A dash B I don't know. So A dash B equal to 16 by root 3. So now I have to add, I want the tree's height, so I have to add 1 and 2. So because AC equal to AB plus BC. But AB is nothing but my tree which is fallen down, so I can say A dash B plus BC. So BC in the first case I have got 8 upon root 3, and in the equation 2 I got 16 by root 3 as A dash B. So this will be 24 by root 3. Now if I rationalize it and I multiply numerator and denominator by root 3, I will get 24 root 3 by 3. So if I cut 3 and 24, so I get 8 root 3 meter. So I can say that AC will be 8 root 3 meter. Now, in the third question, it says a contractor plans to install 2 slides for the children to play in a park. For the children below the age of 5 years, she prefers to have a slide whose top is at a height of 1.5 centimeter. So, can I say in triangle ABC, AC is the slide and AB equal to 1.5 meter as installed, and angle C equal to coming as 30 degree. So I can say if I want to find the height of the side, sin 30 will be AB upon AC. So sin 30 will be 1 by 2 equal to AB 1.5 upon AC. So here AC will be 1.5 into 2. So AC will be 3 meter. Now in the second case, for the elder student, he is putting a slide of 3 meter. So angle C equal to 60 degree in the second figure, and AB equal to 3 meter. So there slide AC I have to find, that I don't know. So here also I can use sine. So sine 60 will be equal to AB upon AC. Now sine 60 means root 3 by 2 equal to AB is 3 upon AC. So AC will be 6 root 3 upon root. So AC will be 3 into 2 upon root 3. So if I cut root 3, so I will get AC equal to 2 root 3 meter. So therefore I can say heights of slides are 3 meter and 2 root 3 meter. Now the next question says the angle of the elevation of the top of a tower from a point on the ground which is 30 meter away from the foot of the tower is 30 degree. Find the height of the tower. So let the tower be AB, foot BC equal to 30 meter and angle C equal to 30 degree. So can I say tan 30 will be equal to AB upon BC. So tan 30 means 1 by root 3 equal to AB I don't know, BC is 30. So therefore AB will be 30 by root 3. So if I cut root 3 from this, I will get AB equal to 10 root 3 meter. The next question says a kite is flying at a height of 60 meter above the ground. The string attached to the kite is temporarily tied to a point on the ground. The inclination of the string with the ground is 60 degree. Find the height of the string assuming that there is no slack in the string. So I am given here AB equal to 60 meter, angle C equal to 60 degree, and I have to find AC. So in right triangle ABC, I can say sine 60 equal to AB upon AC. So sine 60 is root 3 by 2, AB 60 upon AC. So directly I can say AC equal to 60 into 2 by root 3. So this will be 120 upon root 3. Now a 1.5 meter tall boy is standing at some distance from a 30 meter tall building. The angle of elevation from his eyes to the top of the building increases from 30 to 60 as he walks towards the building. Find the distance he walked towards the building. So here let us take AB as height of building, and angle ADF is 30 degree and angle AEF equal to 60 degree. Also AF equal to AB minus FB, that is 30 minus 1.5. So that will be equal to 28.5 meter. Now in triangle AFE, AF upon EF equal to tan 60. So 28.5 upon EF equal to root 3. So EF equal to 28.5 upon root 3 meter. Now in triangle AFD, AF upon DF equal to tan 30. So 28.5 upon DF equal to 1 by root 3. So DF equal to 28.5 root 3. Now the distance walked by the boy towards building DE equal to DF minus EF. So that is 28.5 root 3 minus 28.5 upon root 3. So if we have root 3 as common denominator, so this will be 28.5 into 3 minus 28.5. That is 28.5 into 3 minus 1 upon root 3. So that will be 28.5 into 2 upon root 3. So if I rationalize the denominator also together, multiplying both numerator and denominator by root 3, so from a point on the ground, the angle of elevation of the bottom and the top of a transmission tower fixed at a top of a 20 meter high building are 45 and 60 degree respectively. Find the height of the tower. So here if I take, let AB be the building and BC be the tower or the transmitting tower, then AB equal to 20 meter, because they have said at on the height of 20-meter high building, and angle BDA will be 45 degree and angle CDA will be 60 degree. Now let us suppose DA equal to x meter, that is the distance between the observer and the building be x meter, and BC the height of the tower be h meter. So in right triangle BAD tan 45 will be AB upon DA. So 1 equal to 20 upon x. So x will be 20. Then in right triangle CAD tan 60 equal to AC upon DA. So root 3 equal to 20 plus h upon x. So I can say x equal to 20 plus h upon root 3. Now I am giving this as second number. Now from 1 and 2, LHS are equal, so RHS will be equal. So I can say 20 plus h upon root 3 equal to 20. So 20 plus h equal to 20 root 3. So h equal to 20 root 3 minus 20. So that is 20 into root 3 minus 1 meter. So height of tower. Now next it says a statue 1.6 meter tall stands on the top of a pedestal. From a point on the ground, the angle of elevation of the top of the statue is 60 degree, and from the same point the angle of elevation of the top of the pedestal is 45. Find the height of the pedestal. So here I can say let the height of pedestal ABB h meter. So height of statue is given 1.5 meter. Angle ACB equal to 45 degree. Angle DCB equal to 60 degree. So this all are given. So now moving to directly in right triangle ABC, AB upon BC equal to tan 45. So I can say h upon BC equal to 1. So therefore BC equal to h. Now in triangle DBC, DB upon BC equal to tan 60. So I can say 1.6 plus h upon BC equal to root 3. So that means BC equal to, or BC, so 1.6 plus h upon h equal to root 3. So I can say 1.6 plus h equal to root 3h. So 1.6 equal to root 3h minus h. 1.6 equal to root 3 minus 1h. So h equal to 1.6 upon root 3 minus 1. So again I have got two equations. One is BC equal to h. So I have put that here directly, BC equal to h. Now I have got 1.6 upon root 3 minus 1. So rationalizing it, so I am multiplying with root 3 minus 1, numerator and denominator both. So h equal to 1.6 into root 3 plus so rationalizing the denominator, multiplying by root 3 plus 1 upon root 3 plus 1, I am getting h equal to 1.6 into root 3 plus 1 upon root 3 square. So that will be 3 and 1 square, that is 1. So h comes to 1.6 into root 3 plus 1 upon 2. Now next says the angle of elevation of the top of a building from the foot of a tower is 30 and angle of elevation of the top of the tower from the foot of building is 60. If the tower is 50-meter high, find the height of the building. So here I am taking AB equal to h meter, PQ equal to 50 meter and that is building height I have taken as h meter, that is AB, and PQ tower height is given to 50 meter. So now in right triangle AQB, I can say tan 30 will be equal to AB upon BQ. So tan 30 will be 1 by root 3 equal to h upon BQ. So BQ equal to root 3 h. That is one number equation. Now same way in right triangle PQB, tan 60 equal to PQ upon BQ. So tan 60 is root 3, PQ is 50, BQ we don't know. So BQ equal to 50 by root 3. Now this is second equation. Now 1 equal to 2 because both left hand sides are BQ. So I can say root 3h equal to 50 upon root 3. So h will be equal to 50 by 3. Root 3 into root 3, 3. So if I solve it in the integer, now next it says two poles of equal heights are standing opposite each other on either side of the road, which is 80 meter wide. From a point between them on the road, the angles of elevation of the top of poles are 60 and 30 respectively. Find the height of the poles and the distance of the point from the pole. So Here I am taking AB equal to CD equal to H meter. That is height of the poles is H meter. I have supposed that. Now BC equal to 80 meter. That is road. So I am taking CE equal to X meter. So BE will be 80 minus X meter. Now in triangle CDE, CD upon CE equal to H upon X, which is equal to 1030. So I can say H upon X equal to 1 by root 3. So therefore X equal to root 3H. Now in triangle ABE, AB upon BE equal to 1060. So I can say H upon 80 minus X equal to root 3. So H equal to 80 minus X into root 3. So if I solve it, I will get H equal to 80 root 3 minus root 3 X. Here also if I want to solve X, keep X alone. So root 3X equal to 80 root 3 minus H. So X equal to 80 root 3 minus H upon root 3. Now if I give this as first equation, this as second equation, so both are in the X form. So I can say 1 equal to 2. So root 3H equal to 80 root 3 minus H upon root 3. So multiplying, taking root 3 on that side, I will get 3H equal to 80 root 3 minus H. So 4H will be 80 root 3. So H will be 80 root 3 upon 4. So that is H equal to 20 root 3. Now I got H equal to 20 root 3. Putting that value in 1, putting 3 in 1, X equal to H root 3. So that will be 20 root 3 into root 3. So that will be next. It says a TV tower stands vertically on a bank of canal from a point on the other bank directly opposite the tower. The angle of elevation of the top of tower is 60 degree. From another point 20 meter away from the point on the line joining the point of the foot of the tower, the angle of elevation of the top of tower is 30 degree. Find the height of the tower and width of the CD and 20 meter from the pole AB. Okay, so now here let AB be the tower of H meter high. So this is H meter and canal width is BC. In right triangle ABD, tan 30 equal to AB upon BD, that is AB upon BC plus CB. So I can say 1 upon root 3 equal to H upon 20 plus X. So 20 plus X equal to H root 3. So x equal to h root 3 minus 20. So this I am giving as one number. Now in right triangle ABC, tan 60 will be AB upon BC. So root 3 equal to h upon x. So I can say x will be h upon root 3. This is 2. Now both 1 and 2 will be equal because both are the values of x. So 1 equal to 2. So I can say h upon root 3 equal to h root 3 minus 20. So if I bring both the h values on one side and 20 on another side, so 20 equal to h root 3 minus h upon root 3. So doing LCM root 3, so 3h minus h equal to 20. So 20 equal to 2h by root 3. So h will be equal to 20 root 3 upon 2. So that is 10 root 3 meter. Now this I am giving as 3. Now putting 3 into I will get x equal to h upon root 3. This was the equation. So now next it says from the top of a 7-meter high building, the angle of elevation of the top of a cable tower is 60 degrees and the angle of depression of the foot is 45 meter. Determine the height of the tower. So here I am saying let height of tower is h plus 7 meter because 7 meter high building is there. Against that then I am having the tower. So CD equal to 7 meter, that is height of the building. Now coming to the solution, see before that let me write all the values. Angle ACE equal to 60 degree, angle ECB equal to 45. So therefore angle CBD equal to 45 degree also. Now if I start solution, see in right triangle CDE, CD upon DB equal to 1045. So therefore 7 upon dB equal to 1. So therefore dB equal to 1. Oh sorry, 7 meter. dB will be 7 meter. Now in triangle AEC, AE upon CE equal to 1060. So h upon 7 equal to root 3. So h equal to 7 root 3 meter. Now AB equal to h plus 7, that is 7 root 3 plus 7. So that is nothing but if I take 7 common, root 3 plus 1, 7 into root 3 plus 1 meter. So height of Next it says, as observed from the top of a 75-meter high lighthouse from the sea level, the angle of depressions of two ships are 30 degree and 45 degree. If one ship is exactly behind the other on the same side of the lighthouse, find the distance between them. So, given angle ADB equal to 30 degree, angle ACB equal to 45 and AB equal to 75 meter, that is lighthouse. Now, let us suppose let the distance between the ships be x meter. So, now coming to the solution, in right triangle ABC, tan 45 will be equal to AB upon BC. So, here 1 equal to 75 upon y, as we have supposed BC as y. So, therefore I can say y equal to 75 meter. So, let us take this as 1. Now, same way, in right triangle ADB, tan 30 equal to AB upon BD. So, therefore, 1 upon root 3 equal to 75 upon x plus y. So, x plus 75 equal to 75 root 3. I have put the value of y as 75. So, I am putting from 1. So, therefore, x equal to 75 into root 3 minus 1 meter. So, distance Next it says, a 1.2 meter tall girl spots a balloon moving with the wind in a horizontal line at a height of 88.2 meter from the ground. The angle of elevation of the balloon from the eyes of the girl is an instant is 60 degree. After some time, the angle of elevation reduces to 30 degree. Find the distance traveled by the balloon during the interval. So see, if I make a simple diagram of this as shown, so AB is the starting point and DE is the ending point, and the height of the balloon at that time from the ground is 87 meter, as the total distance is given 88.2. So let us write, let the first position of the balloon is A, and after some time at D. The vertical height ED equal to AB, that is 88.2 minus 1.2, that is 87 meter. See, why 87? Because I have reduced the 1.2 meter height of the girl, because that is seen by her eyes. So now in triangle ABC, tan 60 degree will be AB upon BC, So I can say root 3 equal to 87 upon BC. So I can say BC equal to 87 by root 3. Same way in triangle DEC, tan 30 will be DE upon CE. So 1 by root 3 equal to 87 by CE. So CE equal to 87 root 3 meter. Now distance travelled by the balloon from A to D is BE. So BE equal to CE minus CB. So that is 87 root 3 minus 87 upon root 3. So if we do LCM as root 3, it will become 87 into 3 minus 87. So that is 87 into 3 minus 1 upon root 3. So that will be 87 into 2 by root 3. Now rationalizing it, so root 3. Now next it says a straight highway leads to the foot of a tower. A man standing at the top of the tower observes a car at an angle of depression of 30 degree which is approaching the foot of the tower with a uniform speed. 6 seconds later, the angle of depression of the car is found to be 60 degree. Find the time taken by the car to reach the foot of the tower from the point. So now let the height of tower we have taken as DC, B H meter, and the speed of car be x meter per second. Then the distance covered by car in 6 seconds will be 6x meters, and let the time taken to move from B to C be t second. So now then the distance BC will be tx meter. Now in right triangle DCB, tan 60 equal to DC by BC. So putting the values, tan 60 means root 3 equal to h upon tx. So therefore h will be tx root 3, that is 1. Now in triangle ACD, tan 30 will be DC upon AC. So putting the values, 1 by root 3 equal to h upon 6x plus tx. So h will be 6x plus tx equal to root 3h. So x into t plus 6 equal to root 3 into root 3 tx. So I can say 6 plus t equal to, see this I got from 1. I have put the h value there directly. So 6 plus t will be equal to 3t. Next it says the angle of elevation of the top of tower from 2 points at a distance of 4 meter and 9 meter from the base of the tower and in the same straight line with it are complementary. Prove that the height of tower is 6 meter. So we have to show that AB equal to 6 meter. So let the height of tower AB equal to h meter. First I am supposing that, and we are given PB equal to 4 meter, QB equal to 9 meter, and angle AQB equal to theta and angle APB equal to 90 minus theta. As he has said, both are complementary angle. Complementary angle means sum of two angles is 90 degree. So here in triangle ABP, tan 90 minus theta will be equal to AB upon PB. So tan 90 minus theta means cot theta equal to h by 4. So h equal to 4 cot theta. Same way in triangle ABQ, AB upon QB equal to tan theta. So h upon 9 equal to tan theta. So h equal to 9 tan theta. So if I give this as one number, this as two number. So 1 and 2 says h into h equal to 4 cot theta into 9 tan theta. So that will be h square equal to 36 cot theta into tan theta. So I can say h square will be 36